Hello, my name is Gower-Fici, and today I'll be discussing particle physics. As young students, most of us were taught that the smallest particles were atoms. However, there are smaller particles called elementary particles. The types of these elementary particles consist of hadrons, leptons, and bosons. Hadrons are heavier particles that have been subdivided into mesons and baryons. Baryons consist of protons, neutrons, lambda, and antiprotons, while mesons consist of pi minus, pi plus, and K particles. All hadrons are made up of quarks, while baryons are made up of 3 quarks or 3 antiquarks. Mesons are made up of a quark and an antiquark. Leptons are lighter particles that consist of electrons and neutrinos. The third type of elementary particles are the bosons. Bosons can be split up into gauge bosons and scalar bosons. Gauge bosons consist of Z and W bosons, photons, and gluons, while the scalar bosons consist of the Higgs boson. These three elementary particles are called elementary particles because they have no internal structure or are not built up of smaller particles. The image on the right side of this slide is a representation of a proton that is built up of 3 quarks, 2 up quarks and a down quark. Moving on to the Standard Model, which is a name given in the 1970s to a theory of fundamental particles and how they interact. It classifies all known elementary particles and describes 3 of the 4 known fundamental forces in the universe. The 4 forces are gravitational, weak, electromagnetic, and strong. These forces act on certain particles and are mediated by certain force carriers. The gravitational force acts on all particles and is mediated by the graviton. The weak force acts on quarks and leptons and is mediated by the W+, W-, and Z particles. The electromagnetic force acts on charged particles and is mediated by the photon. The strong force acts on quarks and gluons and is mediated by gluons. Also within the Standard Model is the Higgs boson. The Higgs boson was proposed to explain the process by which particles can acquire mass. Within the Standard Model, quarks and leptons are split up into 3 generations. As generation increases, so does mass. For the quarks, in the first generation are the up and down quarks, in the second generation are the charm and strange quarks, and in the third generation are the top and bottom quarks. For the leptons, in the first generation are the electron and the electron neutrino, in the second generation is the muon and the muon neutrino, and in the third generation is the tau and the tau neutrino. When particles interact and react with one another, 3 things must be conserved for the reaction to work. The charge of the products and the reactants must be constant throughout the reaction. All quarks have a baryon number of 1/3 and all antiquarks have a baryon number of -1/3. The baryon number must remain constant in the products and the reactants for a reaction to take place. Each lepton has a lepton number of 1 and each antilepton has a lepton number of -1. Lepton number as well must remain constant throughout the reaction in order for a reaction to take place. Thank you for watching.